This video recaps everything we did in class today in 8th grade honors math on January 20th. I skipped directly to slide 3 in Classkick. I got here by clicking click here on the Unit 4 Lesson 7 Makeup Work and Recap page. And I skipped directly to slide 3 because we're going to just talk about activity 7.2 and 7.3 since those were the most important ones from class today. We sorted this list of equations into two types: equations that are true for all variables and equations that are true for no values. I said variables. I meant true for all values and true for no values. For example, this first equation up at the top is true for all values. The reason why it's true for all values is because I know that when I pick any number to be n, let's say n is 5, n equals n will be true because 5 equals 5. Let's say I picked 12 to be n. 12 equals 12. So any number for n, any possible number that I choose to replace with n, will make the equation true. Now, in contrast, if I look at an equation like 3 parentheses n plus 1 equals 3n plus 1, I know that this equation is never true. Here's the reason why. 3n plus 1 with the parentheses is equal to 3n plus 1. If I distribute my 3 to 3n plus 3 equals 3n plus 1, I know that I can't pick any number to be n that will make this equation true. Because what this equation is essentially saying is that if I multiply a number times 3 and then add 3 on the left, but only add 1 on the right, the left and the right will be equal. That's not possible because I know that 3n and 3n will definitely be the same, which means if I have two terms that are the same and then I add something different, a 3 and a 1, it will never be true. And so this equation is never true. Your job is to look at the rest of the equations and decide whether they are always or never true. Please pause this video and complete these 8 equations. You should have decided whether these remaining 6 equations are always or never true. True for all values or no values. You can check your solutions in the main Thursday folder because I've posted our class notes and you can see everything we wrote there. The next thing we talked about was question 2. Write the other side of the equation so that this equation is true for all values of u. Well, I know that in order for the equation to be true, no matter what u is, I need the left side to look like the right side. So I'll need to be multiplying 6 times u minus 12. I distributed the 6 plus 2. And that's one way that I could guarantee that my left side is equal to my right side. Because all I did on the right side that's different from the left is distribute the 6. Now, another way that I could have written this that would have made it true is I could have simplified by adding the 2 to the negative 12. 6u minus 10. I know that this will be true for any value of u because what I wrote on the left side is exactly the same as what I wrote on the right side, and it will be simplified as such. In question 3, we want to write an equation that's true for no values of x. Go ahead and try question 3 on your own. Okay, you should have given question 3 a try. Again, you can take a look at our class notes to see some of the examples we had. The most important thing about your example is that you need to be multiplying 6 times u and then adding something different than what we added on the left side of the equation. We know that our equation will never be true if we're multiplying by the same number, but adding something different. Because that means that 6u plus 1 won't be the same as 6u plus negative 10 or 6u minus 10, which is what we have on the right. since the 6 u's will be identical, but one side is subtracting 10 and the other is adding 1. Let's take a look at slide 4. 7.3. 7.3 says, complete the equation so that it's true for all values of x. Then, in question 2, complete the equation so that it's true for no values of x. Go ahead and pause this video to give it a try. I'm just going to show you 2 examples, one that's true for all values and one that's true for no values. In question 1, we know that we want the left and the right side to be equal because it's going to be true for all values of x. And so if I have 3x plus 6, I know that my equation will be equal if I replace the blank with a 3. Or, I'm sorry, a 2. I'm thinking about addition. It's multiplication. Because then, when I distribute my 3 to the inside of my parentheses, 3 times x and 3 times 2, I end up back at 3x plus 6. Now, in contrast, in question 2, if I put a 1 instead of a 2 in the blank, I know that my equation would never be true, because when I distribute the 3, I end up with 3x plus 3. 3x plus 3 can never be equal to 3x plus 6 because I have the same initial term and a different constant term, or I'm adding a different whole number. Once again, you can always return to the Thursday folder to check your work for B and C, which for the sake of time, I'm not covering in this video. In summary, we know that an equation will be true for all values of x when both sides are equivalent. That might require us to do some simplifying, like combining like terms, but just like in this example here, we knew this was identical because 3x plus 6 is the same as 3 times parentheses x plus 2 when we distribute the 3. An equation is true for no values of x when the coefficient on x is the same, and what that means is we are multiplying x by the same number, but the constant term, the number we are adding or subtracting, is different. Because that means that we're multiplying x by the same thing to get this same exact term, then adding a different number. And so the two sides of that equation can never be equal. When you're finished with today's classwork, make sure you head back to the main folder to take a look at today's homework. If you have any questions, you need to send me an email.